domains, and other transforms are there. Z transforms. Yes. Is it visible?
Yes, sir.
This n is a discrete time domain. For this, we are going to use another transform named as Z transforms, which we are going to deal later. Is that clear? So now, for time being, we are going to concentrate only on the continuous time domain. Now, let me tell you definition of the Laplace transform. Now you may ask, sir, why we have to learn these transforms? These
वाइस
transforms.
क्लियर कर सकती थी
Yeah.
वाइस क्लियर कर
Yes.
सकती थी
Voice is not clear.
Yes.
Shall I talk a little bit slow?
Yes, sir.
Okay. See, these transforms. These transforms are used to solve differential equations. Differential equations. Okay. Differential equations. Please, you can represent your circuits. LR circuits, LCR circuits, already you are familiar with them, and you already know, you already solved second and higher order differential equations in your second semester, isn't it? See, just consider this: d square by dx square to dy by dx plus y of some if it is f of x plus y of if it is f of x. Okay. Now, what kind of equation is this? This is a second order non-homogeneous differential equation, isn't it? Am I right? Now, to solve this, what you need? We need to find a solution of this is given by in terms of Cm plus Pi, isn't it? Complementary function plus particular. This is earlier method. Is it clear now? Is it
Yes,
clear?
sir.
Yes, sir.
Yes, sir.
Complementary function plus
Yes,
particular
sir.
integral. Whereas by applying this Laplace transform technique to this, you are going to get directly the solution. You are not supposed to find this CF and PI separately. Okay, CF and PI separately. You can solve it directly. This is one of the application. Okay. Now coming to the directly to the Laplace transform. See, let us define that. Yes. Now we will define Laplace transform of a yes. Laplace transform of a function. See, the Laplace transform of a function f of t, where t is a time variable, continuous time variable, is denoted by L of f of t. That is the Laplace transform of f of t, and is defined as, how are we define this? Defined as yes, Laplace transform of f of t is equal to integration 0 to infinity e to the power minus st into f of t dt, where this t is a positive time. T is greater than or equal to 0. Clear my point? And you may ask now, what is this S, sir? This S is a parameter. S is a parameter. Now, what change is taking place here? You are applying this Laplace operator on this f of t time variable, and it is converting. See, purely this will be after simplification. This will be purely in terms of s and some constants. Purely in terms of this s and some constants, which is called a signal domain or frequency domain. See, basically this is a time function. After applying Laplace to this, After applying Laplace to this, that is converted into signal domain. Is that clear? So now this basic definition you need to remember, which plays a very important role in throughout your Laplace transforms. Is that clear?
Yes, sir.
So anyone you can say it is clear or not? Definition is clear?
Yes, sir.
Okay, shall I write this now? So therefore Laplace transform of f of t. Laplace transform of f of t is denoted by integration 0 to infinity e to the power minus st into f of t dt. T is greater than or equal to 0. This can also be represented as other notation for this is f of s. Sometimes we will write this one as f bar s. Shortcut notation for this L of f of t is what? Capital F of s or f bar s. Usually I am going to use this f bar s. What this bar indicates? Bar indicates, I tell you, this after operating Laplace operator on this time function, this bar indicates it is changing in terms of s. Time domain is changing in terms of signals, or you can say frequency domain, which is very useful for ENC students when you study what? Your other subjects like signals and systems, network analysis, and many more applications are there. You can remember these results and you can apply this knowledge in those subjects. Okay. Now, what we will do? We will discuss about the two main properties. After that, we will go to some other things, but first we will discuss about the linearity property. Linearity property. Laplace operator is a linear operator. What do you mean by this? Laplace operator is a linear operator. See, if I write Laplace transform of E into, or you can take some other number, alpha into f1 of t plus or minus, you can write beta into, say I take fn, beta into g of t. Okay, this is the one function, different function. This is other. So Laplace transform of product or sum or difference of two functions if it is there. Now linear operator means what? You can operate this operator term by term to these two operators separately. You can operate Laplace operator to these two operators term by term separately. That is, you can write it as alpha into Laplace transform of f of t, Laplace transform of f of t plus or minus beta into Laplace transform of g of t, Laplace transform of g of t. If you want, you can make down notes there. Okay, Laplace transform of g of t. Agree? Now, so therefore, this Laplace operator, it can be operated term by term. So it is a linear operator. Meaning is Laplace operator, you can operate it term by term separately to the n number of terms. If it is a sum of n number of terms, or if it is a difference of n number of terms, it can be operated. Whereas one thing you need to remember, if it is a Laplace transform of f of t into g of t, is that, see, you cannot write it as Laplace transform of f of t into Laplace transform of g of t. You cannot write. This is not valid. Okay, this is not valid. So what you have to do? You have to reduce it to by using partial fraction method or any other method. You can reduce you must reduce product of these two functions to sum or difference. Then you can use this linearity property. So if it is product, this rule is not valid. Is that clear? Is that clear? Is the speed
Yes,
is
sir.
okay? This speed is okay. Shall I reduce a little bit speed?
Okay, sir.
All of you, is it okay?
Okay, sir.
It is okay, sir.
Sir, voice is clear?
Yes, sir.
Clear? Audible?
Yes, sir.
This is number one. One more thing is, let me tell you one more property, very easiest property. It is Laplace transform of some constant c into some function f of t into some function f of t. What you can do is, you can take this c outside, which already we have discussed. Still, you can take this c constant outside and you can operate this Laplace operator to this function directly. These two basic properties, if you remember, that is sufficient. What you need to remember? You need to remember this definition, okay? This definition and these two basic properties. If you forget these basic properties also, no issues, but you should remember this definition. Will you remember? Will you remember?
Yes, sir.
Yes, sir.
Now,
Yes, sir.
now what we will do? Actually, 8 or 9 standard functions are there. 8 or 9 standard functions are there. Actually, those are proof of those are not for your syllabus. But I want to prove those results which are very, very simple, because you must know how they came. Okay. So, using this definition, we will learn some Laplace transform of some standard functions or basic functions. Shall we learn? In short, I am going to write as LT. Is it okay? In short, I am going to write as a LT. That is Laplace transform. Okay? Shall I write it? Shall I write it? Is it okay?
Yes, sir.
Laplace transform of yes. Yes.
Sir, write little bit below.
Slow.
Below. Right.
What's up? Quickly, don't waste the time.
Right below, sir.
Laplace transform of
Write it below, sir.
some. Huh? Laplace transform of some standard function. Shall we take one by one? Shall we take one by one? First one, I will take a Laplace transform of 1. Laplace transform of 1. Or you consider some constant here. Let us take Laplace transform of k. Laplace transform of k. Clear my point? Clear or not? Yes or no?
Yes, sir.
Yes, sir.
Laplace transform of k. It can be written as integration 0 to minus t e to the power minus t dt where less greater than or equal to 0. Am I right? Definitely. Because your k is constant here, I am taking k outside, and if you take k outside, it becomes 1 here. So this is Laplace transform of what is your f of t here? This is because your f of t is 1. Your f of t is 1. So by the definition of Laplace transform, what should happen? Integration of 0 to infinity e to the power xt, that is exponential function, that is fixed. F of t is 1, so 1 into infinity. Is that clear? So now this k I am going to keep it as it is. So what is the integration of e to the power minus st?
E raised to.
Is e to the power minus st divided
To
by
the minus.
minus.
Minus S.
Am I right?
Yes, sir.
You are integrating with respect to t. Yes, is treated as a constant. Okay. And this is integration is equal to infinity. If you want, you can put some here. Then next, what I will do, k as it is. See, in place of t, I can write here. If you want, you can write t is equal to 0 to infinity because you are integrating with respect to t. Now, t is equal to 0 to infinity. Wherever t is there, you have to put upper limit and lower limit. Okay. Further, what I will do? 1 divided by minus s is constant. You need to I will take that out. Then I will put the upper limit. What is the upper limit?
E raised to minus S.
E to the power minus infinity. T is equal to infinity. Anything into infinity is infinity.
Minus
What is the lower limit?
S.
1.
0.
Agree? Now, I will take e divided by minus s like this. So can anybody tell me what is the value of e raised to minus infinity? E raised to minus infinity value is 0.
0.
Plus or minus is 0. Minus e to the power 0
1.
is 1.
1.
So, like that, e to the power minus infinity value is 0. So, this term goes to 0. Okay.
0.
Now, e to the power 0 is 1. So, if you simplify this, what happens? Minus divided by minus, it is what? Plus.
Plus
So, you get that?
K
A
by
by
S.
S. So, what is your final conclusion? Laplace transform of k is
K.
you can write as 1 by r. So you can write directly k by. Okay. Just one second. If you want, you can put it down. Now, if I put k is equal to 1 in this, if I put k is equal to 1 here, then what happens?
1 by
If
S.
I put k is
E
equal
raised to
to 1 in number 1, it becomes Laplace transform of 1.
1.
Okay. So directly what you can write? Laplace transform of 1 is
1 by
1
S.
by x.
Yes.
Okay. Now can anybody tell me what is the Laplace transform of minus 2? That's very good. Tell me. What is the Laplace transform of minus 2?
Minus 2 by S.
Yes. Yes.
Minus 2 by S.
Yes. Minus 2 by.
Yes.
Definitely. Like this, sir. No need to remember all these steps. For your understanding purpose, how you got this result, you must know. For that purpose, I took this. So remember only this result, that is sufficient. That is Laplace transform of 1 is 1 by s. Or if they give some number, constant number, Laplace transform of that constant number is that number divided by s. That number divided by s.
Yes.
Is that clear?
Yes, sir.
Are you going to write this?
Taking shot. Screenshot.
Are you making notes of this? Yes or no?
Yes, sir.
Yes, sir.
If you want, we can make. Otherwise, I'll try to send a PDF copies notes in your group. Okay. Just one thing is, whether you
Yes, sir.
understood this or not, you have to at least reply now. May I rub this?
Yes, sir.
I rub this. Now, see, basic definition is
Yes,
very
sir.
important. Now I will go to the second one. Okay. So let me take this as f of t is f of t is e to the power minus e to the power a into t, where a is constant. Where a is a constant.
Constant.
Okay. So now, therefore, Laplace transform of f of t. This can be written as what?
Integration of 0 to infinity.
Yes, integration 0 to infinity e to the power minus is constant fixed. Now, what is your f of t?
E raised to 80.
You can write this one as e raised to 80. Sorry, e raised to 80 dt. If you want, you can write t greater than or equal to 0. Otherwise, you can simply leave that. No need to worry. But you must know t is greater than or equal to 0. Positive value. Okay. Is that clear? This is
Yes, sir.
by the definition of Laplace transforms. Now, you have to simplify this integral. How you are going to simplify? See, these bases are same, so you can add the powers.
Yes,
You can
sir.
add on. So I write this one as integration 0 to infinity e to the power. See that in both first I write this.
Minus t form.
Minus st plus 80 dt. This is one step. Integration 0 to infinity e raised to. From these two you can take a t common outside there. Okay. You can write it as a
A minus s into t.
a minus s into. Okay. Now this s is also constant. A is also constant. Only this t is now. You are integrating with respect to t. Okay. Now what is integration of e to the power minus? Sorry, e to the power some constant into t. It is e raised to a minus s into t divided by a minus s. This is 0 to
Infinity.
am I right? Next. I'll simplify, then afterwards I'll give 2 or 3 minutes to time. If you have any queries, you can ask me. Then therefore, this is 1 divided by a minus s. I will take out some. Then I start putting the values. What happens?
E raised to a.
A minus s, a minus s into infinity. What it becomes?
0. Infinity.
Am I right?
Yes, sir.
Minus, put t is equal to 0. This becomes 0. Agree?
Yes.
So again, this goes to 0. So finally, what will you get here? 1 divided by
yes.
a minus s. This is agree. So
Yes,
now you will get this one as a minus 1 divided by
a minus s.
s. But you are not supposed to write like this because I forgot to say one thing here. S will be greater than 8. So what you should do? This is 1 divided
1
by
divided by s minus
8. S minus 8. S is greater than
8. Greater than 8.
Greater than 8. You can write. Okay. If you take equal to, then what happens? If you take s equal to 8, it becomes 0. If it becomes 0, it is 1 divided by 0 is infinity, which is not defined. Agree? Agree or not? Therefore, what is your conclusion? Laplace, see, you can use this notation or this notation you will choose. Laplace transform of e to the power 8 is 1 divided by
s minus 8.
s minus 8. Now, after learning this, I will write one result directly here. Therefore, Laplace transform of e to the power minus 80. What do you expect? What do you expect this?
1 divided by s plus a.
Yes, only wherever a is there, replace that a by, it is plus a here, you are getting minus a. You replace this a by minus a. Here if you write it as a minus a, minus into minus, it becomes a
Plus
a. Therefore, what you can write? 1 divided by s plus a. Is that clear?
Yes,
Is
sir.
that clear? Okay. Is this visible now? This part is visible?
Yes, sir.
And this one? Visible?
Yes, sir.
Okay. Now tell me, using this result, I want to write that Laplace transform of e to the power 2t. What do you expect your answer? What is your answer here? See,
1
compare
divided
this.
by s plus 2.
Okay. In place of a, you have 2 here. So you can write directly. So the result
1
as 1
divided by
divided
a
by
minus 2.
yes minus 2. If I write Laplace transform of e to the power of minus 9 into t.
1 divided by s plus 9.
Okay. What's the name?
Mayuru Udgatti.
Mayuri. Mayuri Udgatti.
Yes, sir.
Mayuri Udgatti. Good. Now, can anybody answer me this? Laplace transform of e to the power sorry e to the power bt minus bt. Yes,
1 divided by s.
Yes plus
d.
Likewise, you are not supposed to remember all these steps. Finally, if you remember only these 2 steps and how to apply when situation demands, if you remember, that is sufficient. I have derived these results because you must know how you got these results finally. If I write directly, you will be under confusion. Is that clear?
Yes, sir.
ಇದು ಎಲ್ಲಿಂದ ಬಂತು ಯಾಕೆ ಬಂತು ಕನ್ಫ್ಯೂಷನ್ ಇರ್ತದೆ ಇದೆಲ್ಲ ಸಿಲೆಬಸ್ ಒಳಗೆ ಇಲ್ಲದ್ರು ಇದನ್ನ ನಾವು ಡಿಸ್ಕಸ್ ಮಾಡೋಣ ನೋ ಇಶ್ಯೂಸ್ ಓಕೆ ಸಿಲೆಬಸ್ ಅಲ್ಲಿ ಡೈರೆಕ್ಟ್ ರಿಸಲ್ಟ್ಸ್ ಹೋಗಿಲ್ಲ ಅರ್ಥ ಆಯ್ತಾ
Yes, sir.
okay and now shall we go to the next result
Yes, sir.
okay how many
Yes,
results
sir.
we got now first basic thing is Laplace transform definition okay
Yes, sir.
second properties how many standard functions Laplace transform of one is 1 by s okay Laplace transform of e raised to at is plus at is not at a into t constant into t constant a into t is 1 divided by s minus a Laplace transform of s e to the power minus a into t is 1 divided by s plus a. These 3 results will be learned now, right?
Yes, sir.
Agree? Now, shall we go to the next results now?
Yes, sir.
Yes, sir.
Final results, okay? Sunil, class yaar umrane
Mari.
Yes, sir.
umrane adala Sunil Sagar
Sagar Umrani, sir.
Sagar ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸ್ ಕೇಳಿ ಹೇಳಿದ್ರು ನನಗೆ
Yes, sir.
okay I love this also now next one is we take that as the third one okay f of t we take that as a sin a into t. Usually I will be taking a here in your books also they have taken a. If you want you can take any constant p, q, b, anything you can take. Okay. Here. This is standard notation. This is standard notation for so we are considering it as a a. Okay. Now see your f of t is this one that is sin a t. Now I want to find that Laplace transform of sin a t is equal to a divided by s square plus a square. A divided by s square plus a square. See, we will derive this. Don't worry, we will derive this. Okay. If f of t is sin a t, then handwritings are understandable, no? Handwriting, are you understanding?
Yes, sir.
Because
Yes,
some
sir.
people do not understand. If they do not understand, you can ask me somewhere if you have any difficulties. No issues? See, consider Laplace transform of t is equal to how are you going back? Integration 0 to infinity. Now this is your f of t. So what is this? e to the power minus t into sin 80 dt. Agree? Now, my question is, how you are going to simplify this?
U into V.
See, if you use 0 into 0, this is one function, this is another function, right? Okay. If you take this as a first function, this as a second function, if you go on differentiating, this is continuous to the end. Okay.
Yes, sir.
If you take this as a second function, then also integration or differentiation of this also same thing. It continues, isn't it?
Yes, sir.
So, to simplify this, I want to recall one of the results from your PUC second year. That is, yesterday I told you, but I think you don't remember that. If it is e to the power ax into sin bx dx, in your PUC second year, you have obtained by substituting and simplifying, you have obtained one standard result for this. What is that? E to the power ax divided by a square plus b square into bracket a into sin bx minus b into cos bx. Do you remember this? Do you remember this?
Yes, sir.
All of you remember this?
Yes, sir.
If you remember this, compare this. Don't worry about the limits. Compare this result with this. Okay, what happens? In place of a, you have minus x here. In place of b, what you have? A. Replace this here. So what happens? That becomes, I write here, e to the power minus st divided by, this a is what I write here, minus s square. A is minus s, no, plus b is
A square.
s square into bracket a sin bx. A is what? Minus s.
Minus
sin
s.
bx is what we get here?
Sin ax.
Sin bt minus b. Sorry, b is what? B is a. Then this is cos. What is your a? Sorry, what is your b? Cos 80. Then this is from 0 to infinity. All of you agree? Agree or not?
Yes, sir.
See this result, please concentrate. This result we are going to use again and again in the Fourier series also, Fourier transforms also. So at least you must remember this result. Okay?
Yes, sir.
Now, I will put the limits. Before putting the limits, what I will do, I will try to simplify it further. That is, see, this S is also constant, A is also constant, so no need to write it again and again. So I will take that outside. 1 divided by minus S whole square is, that becomes S square. This is plus A square. Now, this term only contains a T. Agree to this, sir? See here.
Yes, sir.
This term contains T, this term contains T, this term contains T. So I need to consider only put T is equal to infinity there. Now, if I put e raised to infinity here, what happens?
0.
0. 0 into this quantity.
0.
Upper limit is what? Upper limit is, all of you. If I put infinity here, this is upper limit minus lower limit you have to do, isn't it?
Yes, sir.
Integration a to b, f of x dx, then you have f of b
minus f of a.
Agree? So, infinity ಹಾಕಿದ್ರೆ ಏನಾಗುತ್ತೆ? It's 0 ಆಗುತ್ತೆ. 0 into no need to calculate this. If you calculate this also, that is also 0. Isn't it?
Yes, sir.
So, upper limit is 0 minus. I will come to the lower limit. Lower limit ಅಂದ್ರೆ ಇಲ್ಲಿ 0 ಹಾಕ್ತೀನಿ. 0 ಹಾಕಿದ್ರೆ ಏನಾಗುತ್ತೆ?
Minus 1.
Into bracket. Please concentrate. Into bracket. Minus s I will keep as it is. Wherever t is there, I will put 0. Sin 0 is 0 minus a. Cos 0 is
1.
agree? Agree? So what happens? This becomes 0. This becomes 0. You left with the only this term. Agree? So This minus into this minus what?
Plus
Plus. So what happens there?
A
Finally,
divided by
A divided by
S square plus A square.
square plus A square. So what is your conclusion? I'll write there. Okay, I'll write there. Otherwise, I'll write here only. Therefore, Laplace transform of sin AT is what? A divided by S square plus A square. One condition should apply there. Okay? Agree with this? All of you perfect with this result?
Yes, sir.
Are you going to remember this?
Yes, sir.
Okay. Now let me ask you one simple question. With this, today's class is sufficient. I hope, shall we take one more result or is it sufficient?
One more result.
One more result. Okay. Now, this is Laplace transform.
No, sir, it is sufficient.
Laplace transform of if I write sin 3t directly, how do you write this?
3 divided by S square plus 9.
3 divided by S square plus, usually it is a 3 square, that is 9. Agree? Because 3 is equal to A over 9. Am I right?
Yes, sir.
If it is Laplace transform of sin of minus 2t.
Minus 2D.
Yes, yes.
Minus
Don't
2
worry.
divided by
Minus 2 divided by
S square plus
plus minus 2.
4.
Or you can write it as a 4. Is that clear?
Yes, sir.
Now, are you going to remember? No need to remember all these things. Just remember Laplace transform of sin AT is A divided by S square plus.
A square.
We will take one more result, then we will conclude the class. Okay? Hope you are understanding all these things.
Yes, sir.
Only one girl is saying yes. Sagar.
Yes, sir, understanding.
Did other Patel Pradeep Yaro? That party is absent today?
Sir, present, sir.
But Matado. Okay. Shall we put the next result? Next, we go to very simple.
Yes, sir.
Just I'll grab this. I'll grab this. I'll grab this also. I'll grab this also. I'll grab this also. Then next result. Okay, I'll grab this also. No issues. Okay. Number 4. If f of t is cos A into t, then Laplace transform of cos A into t. What do you expect? This will be S divided by S square plus S. S divided by S square plus. Shall we do this? That is Laplace transform of cos A. By the definition, what should happen? Integration 0 to infinity.
Yes,
E
to
to the power minus infinity. Then this is cos AT. Now how you are going to simplify this? Again for this, you have one more standard result. What is that? E to the power ax into cos bx dx. This is equal to, this part is same. A raised to x, sorry, e to the power x divided by a square plus b
plus b square
plus a into this is
sin b
cos bx. This is plus b into sin bx. b into sin bx. So, in place of a you have minuses, in place of b you have pluses. So, a here. So, directly we simplify. This is equal to e to the power minus st divided by this is minus s whole square and this is plus a square into bracket minus s into this is cos 80, then this is plus b is what here? A, then this is sin. Very simple. Integration 0 to infinity. 1 divided by s square plus a square as it is. Again, upper limit. Upper limit is what? Infinity. So e to the power infinity becomes 0. 0 into this is 0. No need to worry. No need to worry. Minus. Put s is equal to 0 here. Sorry, I am sorry. T is equal to 0. If you put t is equal to 0, e raised to 0 is 1 into bracket minus s as it is. Cos 0 is 1 plus a into sin 0 is 0. Right? Am I right?
Yes, sir.
So this term is 0. This term is 0. You left with only this term. So s into minus s into 1 is minus s. Then minus into minus is plus. So finally what you will get?
S divided by s square plus a square.
S divided by s square plus a square. Okay. Is that clear? Clear or not?
Yes, sir.
Find the conclusion. Laplace transform of again. Therefore, Laplace transform of cos 80 is s divided by s square plus s. Is that clear?
Yes, sir.
Some results.
Yes, sir.
Some questions on this will take tomorrow. But right time being, just always when you come to the next class or when you finish off a class, you should remember at least glance what you learned. What you learned in the today's class? Laplace transform f of t is integration 0 to infinity.
T e raised to minus s f of t into
Definition. Properties will you then Laplace transform of 1 is 1 by s. Second one is Laplace transform of t to the power 8 is 1 divided by s minus s. And one more thing is Laplace transform of e is to minus 8 is 1 divided by s plus a. Third one, Laplace transform of
sin 80.
sin 80 is a divided by
S square plus a square.
square plus a square. Laplace transform of cos 80 is s divided by
Divided by a square plus a square.
s square plus a square. What is the difference between these two? Denominator is same. If it is cos, constant term. If it is if it is sin, constant term. If it is cos, yes, variable will be there. Is that clear?
Yes, sir.
Okay. Shall we conclude today's
Yes,
class
sir.
now?
Yes, sir.
Okay, sir.
Yes, sir.
Hope all of you understood today's class 100%.
Yes, sir.
Yes, sir.
Yes, sir.
So hope this method will be adaptable for you. Is it easy?
Yes, sir.
Yes, sir.
Sure.
Yes, sir.
See, one more
Yes,
thing.
sir.
If you feel my speed is little bit high, you can tell me. I will reduce it. If it is too slow, also you can tell. I will decrease it. Okay.
Yes, sir.
Okay, sir.
Now we are going with a 35 kilometers per hour. If you want, we will make it a 40 or 30. Or will it be okay?
Is it okay?
It's okay, sir.
Okay.
It is okay, sir.
Okay. Now we have rest now. Attendance. All of you do one thing. You please call your question numbers. Like that. All of you please call your reversal numbers. Number 1.
Yes, sir.
Yes, number 1. 2. 2, 3. Answer your roll calls, otherwise you will be kept absent. 1, 2, 3, 4,
Yes, sir.
5,
Yes, sir.
6,
Yes, sir.
7, 8, 9,
Yes, sir.
10, 11,
Yes, sir.
12, 12, 15,
Present, sir. Present.
12 is present. No, no, 13 no. 14,
Yes, sir. 13. Sir, 13 is present, sir.
14,
Yes, sir.
15,
Present, sir.
16,
Present, sir.
17,
Yes, sir.
18,
Sir.
19, 20,
Yes, sir.
21,
Yes, sir.
22,
Yes, sir.
23,
Yes, sir.
24,
Yes, sir.
quick, 25,
Present, sir.
26, 27,
Yes, sir.
28,
Present, sir.
29, 30,
Present, sir.
31, 32, 33, 34,
Yes, sir.
35, 36,
Yes, sir.
37,
Yes, sir.
38, 39,
Yes, sir. 39,
40,
yes.